Okay, so I'm gonna share my screen as we go about this. App plus star, app plus star. Okay, so let's just take a quick look at the problem again so we can really think about it. I'm getting a thumbs up. I'm saying it right. Nice. Write a deepDup function, right, that returns a copy of an array of all nested arrays inside. So this is, so let's, to show like what this means, right? So if I don't deepDup, right? So what are some of the ways we know of how to duplicate an array? Can somebody tell me a couple or one way? How do we just make a basic dupe? Oh, sorry. I think someone's right. People are writing in the chat. Let me open that. It closed when I went full screen. Yeah, this thing is in the way. Okay, so cool, right? I'm seeing spread operator. Yep, spread operator is one way. What's another way? Can we think of another way? There's another very common way. Okay, I think I went more a little stumped maybe. Right, the other way is slice, right? Slice can make a duplicate of an array. Both of those are super common. We should be comfortable with both. Right? So, because slice was first, then came spread. Then came a baby and a baby carriage. Okay, so let's pretend I make a dupe here and I say let dupe. And I just set array.slice at 0, right? This is just making a basic copy. Now, if I change the second, well, the third element, second index, so 0, 1, 2, at the 0th, so right here, I could reassign that value to cat. We will see that, in fact, both arrays now say cat, right? Because slice here is doing a shallow copy. So if you remember about arrays, arrays are pointing to a specific location in memory, which is like essentially holding that array. Now, every array is like that. So if it's an array filled with arrays, each of those arrays are also pointing to a specific place in memory, right? So no matter where we are, if it's an array, it's doing that, or really if it's an object, right, too. So when we make a copy, we're just making a shallow copy saying we're gonna copy all of these elements, but just like essentially the pointer of all these elements, not the specific elements in every element, right? Same, this is synonymous with this as well, right? Let me sorry. If I just do ... array, right? This is our spread. Again, this is still a shallow copy, exact same thing. So we need to make a deep copy. So how are we going to make a deep copy? Well, we could make a shallow copy of every array, right? Because if we copied every single array, then we would have a copy of the whole array, right? Does that make sense?
So pretty much like we would iterate through it. If it's an array, make a copy of that array, and then okay, that makes sense. Yeah.
Exactly. So again, this is very much going to be like our flatten, which we've done for the last 2 weeks, right? We had flatten, and then we've had the like flatten product times depth, right? And now we have this deep duplicate. And sorry.
Are we taking the arrays out of the original array?
Well, we're going to be duplicating every array. So we're going to have to iterate through the elements and check if this is an element or an array that we need to duplicate. If it is an array we need to duplicate, we'll have to call our deepDup on that array. right? So let's think about it like this, right? So we need to duplicate this whole array, right? So we can start with having some kind of output. Let's say I say let output, and I have this array. So all of this stuff is going to go inside of this array at some point, right? But we need to pull out all of the elements from inside this array. So let's iterate through it. So I'm going to say array.forEach, and we can look at our element. And now we do our check. So let's say it is just a regular element. What do we want to do with it? Who can tell me?
We want to push it into our
Push it to the output.
Yeah, right. We want to push it into the output array. So we'll say if array.isArray, our element, we'll do something. We'll worry about that in a minute. Else, we'll just push it, output.push our array, our element.
Element.
Yeah, element. Thank you. Right? So we push in our 1, that's going to be in there. We've pushed in our 2, that's going to be in there. And then we say, okay, this is an array. So what do we want to do with this array? What would we want to do?
Loop through it.
Yeah.
Yeah, we would like to loop through it. But even broader, pulling back even more, like what's just the now that we have an array, what would we like to do?
Copy it.
Yeah.
Damn it, took the words right out of my mouth.
Yeah, great minds think alike, right? We just want to copy it. We want to duplicate it. And then whenever we duplicate it, we want to stick it into the original array, right? So do we have a method for doing a deep duplicate? Oh, yeah, it's the one we're writing. Well, that's really convenient. So we can just say output.push and duplicate the element. And we go, okay, great. So whenever, assuming that my deep dupe just works, whenever this duplicates, whenever this has a whole duplicated element, we're just going to push that into the array. And so we can then just return at the end our output. And so, I mean, that's it. It's pretty much the same as Flatten and the other week, right? So now we have our dupe, and we can say deep dupe, this specific array, we're going to change the duplicate, and we're hoping that the original array still looks the same as it's supposed to. So let's give it a shot. And it does. We've successfully duplicated this array.
Why would we ever want to do this? Like, I can understand like doing a function where we're finding all the arrays in the original array and then pulling those elements out of the array to make a new array. But I don't see like how I would use this function to like just duplicate the array.
Okay. Well, I'm trying to think of like real life examples, but like there
I
is.
think I could think of one. Well,
Sure.
shallow copies, like they affect each other, right? So it's in terms of like if you were to like update information on like one on like a shallow copy of a thing, it'll affect the other thing. So I guess like it's a safe way of making a copy of like information, because I don't really think that like I don't think we want a situation where we want to manipulate a copy and have everything else, you know, turned a certain way. I feel like that would be kind of risky. So I think that it's a good way of like protecting data. I'm not sure if I'm like off the ball, but that's the first thing I'm thinking of. Like, how can we protect, you know, how can we like, I don't know, make like a copy that's a bit more secure than just doing something with the spread operator.
Okay, that makes sense. All right, gotcha.
Yeah. So there are libraries like Lodash and probably underscore that have deep duplicates, functions and methods, right? Both for objects and arrays, right? Maybe next week we'll get one about how to duplicate an object. It will be similar, right? But if you think about Redux, when we had like our reducers, which were these pure functions that were supposed to have no side effects and always return the new state, right? Things like that is a case where you might need to do a deep duplication if you have all this nested information. You do not want to be altering the old state, because then it's a side effect and an impure function, and it goes against the Redux flux architecture pattern. So it's, although it's not something we may see every day, it is a good thing to be aware of. And I mean, I was asked flat in an interview. That's pretty much the same thing as being asked this. But that is it. That's a good question, Ashia. Any other questions on this?
Corey, I have a question really quick.
Yeah.
I don't really understand the shallow and deep dupe. I mean, I get the like duplicate part, but what do you mean by shallow exactly?
Okay, sure. So let me uncomment this one back out. So would you agree with me that right now duplicate is a duplicate of our array 1?
No.
Well, tell me more about that.
I'm saying no because we just did a whole function to make a duplicate.
Oh, sure, but yeah, but don't worry about getting the answer right. Just worry about like, because I just want to make sure you understand it, right? So in the past, we've been able to duplicate arrays, right? Let's say I do this, let names, and I say, I should put it in an array, right?
Mhm.
Maria.
I guess my question is, Corey, does it just mean that it's not the same, it doesn't go to the same part of the memory in the RAM?
Yeah, well, I don't want to be able to alter it. So
Okay.
if we had a names thing here and I said let names dupe, and I said names.slice, I'll do it this way, right? It's identical to the spread way. And then I console log both of these, right? Names and names dupe.
Mm-hmm.
And then I'm going to change the name Bill to Bob for whatever reason. And I say name, and I'm just going to do it for the duplicated ones.
Mm-hmm.
Names dupe. This is the index 2, and I'll say that's Bob, right? And then I'm going to reprint our arrays. Oops. I'm going to reprint our arrays after I've made that change, okay?
Mm-hmm.
So what that's going to do is this, right? It's going to say Maria Bill, Corey, whatever, right? So the duplicate one is the same as the original.
Mm-hmm.
And then we've changed the duplicate one, but the original stays the same as well. And the duplicate one shows the changes, right? But the original stayed the same. We didn't actually affect the original because the duplicate was a copy of the original.
Oh, okay,
right?
okay.
So this is about making a copy. Now,
Mm-hmm.
I'm just going to move these out of the way, though. Okay, so that's what we're going for. Here is we've got our array here, and this time it's a multi-dimensional array. So there's arrays inside of it, and then we are making our copy, dupe, but now we're saying, so dupe at this exact moment looks the same as the array, right? So I'm just printing out dupe right now,
Mm-hmm.
and you'll see it looks the same.
Yeah.
And once I change dupe, I can print out, so I'm changing the third element at the 0th index, right? So I'm changing this number 3 just to the word cat for fun, right? And so I'm gonna then print out our duplicate and the original. Now, if this worked the way we might be expecting it to, we would see the original unchanged and the duplicate one with the word cat. But because they're sharing a point in memory, we end up seeing that they now both have cat, duplicate, and the original array,
Mm-hmm.
which is not the desired outcome, right? Because we made a duplicate. Why should our duplicate be affecting our original? That's the whole idea.
Okay, I got it now.
Great. So our deepDup is setting up a situation where we can change the duplicated array without affecting the original, because the spread operator, slice, those all do what's called a shallow copy. So one level deep. Okay. So if it goes deeper than that, it's no longer making a copy. It's just using whatever was in the, as the whole element, it's using that element, even though that element in itself could affect other elements or other items pointing to that element. And that's what this is all about. So we're just making this copy. And so we're doing that by saying we're going to have a new array. And for each element in the array, we will check if it's an array. And if it is an array, we're going to duplicate that array and push that in, because it's still supposed to be nested. Otherwise, we're going to actually push in the element itself, just as it is normal. And then we'll return our output.
So Corey, the dupe line 216. Yeah, so I see that we changed it. It's deepDup array now, but before we had the spread array. So what exactly is the deepDup calling the array on, is calling the function on the array?
Yes. Right. This is just a function invocation with the argument of the array so that it will evaluate into a duplicated array, while this is just doing a shallow copy. We had to write a function to do a deep copy.
Gotcha. Okay.
Cool. What else? Any other questions? Right, so just for fun, right, we could refactor this. We could shorten it. So we'll say deepDup 2. Is there a method that produces a new array for us already without using for each? Is there something that acts on every element?
Map?
Yeah, right? So we don't technically need to use our own output. We could update this to be a map. And so instead of these, we're just, instead of pushing, we'd just be returning. Like that, right? And if we just make those changes, this should also work. Let's check. And it does, right? So this is a little bit cleaner, a little bit sexier, more simple, because instead of iterating through this array and pushing everything into an array after we've done this check, right? We could just be like, well, map already returns an array for us. It can do something for every element. So why not just use map instead? And if it's the right element, we'll just return that, and that will stay the same in its array. Otherwise, we'll just return a deepDup copy of the array. This can be cleaned up even further, right? We could use a ternary. We could say return array.isArray, and we could check our element. So is this an array? We'll just return our deepDup of the element. Otherwise, we'll just return our element. And then we get to get rid of all this code. And now it starts to look really clean, right? And then if you want to get really crazy, right, we actually don't need to return anything. We could use implicit return. And just write like that. And this will still work, right? And we can refactor this even more. We can also write, I don't want to go on a new line because I think that's going to get messy, but we can make this an implicit return by changing these to parentheses instead of curly braces And then this, oops, this will still work as well. All right, so this is a little bit cleaner. I would say if you think it's less readable, then you can stick with this. I don't think this is terribly unreadable, but it's a little tricky. Any questions at all?
I have a question.
Yeah.
In the deepDup 2, you're calling in line 214. You're calling the function, the pry function. Is that what you wanted?
I'm coding the what?
You're calling the other function, the pry
Oh,
function.
thanks. No,
Yeah,
that's not what I want. It should still work though. Yeah, cool. Good catch, Henry. Thank you for that. Did I do that in the other one too? Yeah. Oh, I didn't. I see. Okay. Good catch. I'm pretending this doesn't exist, right? Otherwise, it'd be really ridiculous to write the same.
Yeah, that's how I was like, my confused. I was like, then why do we need all these extra lines?
No, very good catch. Any other questions about this? The steps to refactor. Do we think if we were given a problem that's kind of like flattened but with a twist next week, we'd be able to get it?
Question. On LeetCode, is there like a section where we could do Latin?
I don't think there's a section. I'm kind of curating this list just out of my head.
Oh, okay.
Sorry. But if you find one, let me know. That would be cool. I've been trying to do like, I've got a bunch of pattern problems in my head. Do we know what's coming tomorrow? The pattern continues. So tomorrow will be some kind of object accounting. Okay, so I got some yeps. Cool, I like that attitude. We will get it next week. Keep practicing, keep doing these, right? Got to keep doing lots of repetitions, right? So even when I stop doing flattened problems, because there are other patterns I'll want to address, you should still make sure you remember flatten, right? If you know how to write it, it's not really much of a chore because you can write it in like, get to the point where you can write it in like 15 seconds. And then it's just like, it only takes 15 seconds of your day. It's just to keep it fresh, right? All right, besides that, great job, everybody. Nice work. I'm gonna stop recording.